So here we have another example. We're starting with the absolute value of a quadratic function. And so I've given you some points of reference. So definitely the vertex is going to be a point of reference. I've also given you the zeros because they're nice coordinates. Okay, and we get this graph that looks like this. So once we establish the function, we don't use the calculation to do any kind of transformation to get the new coordinates. We're just going to use our x transformation and our y transformation to get the new coordinates. Okay, although it does make a new function, okay, and we do need to know how to apply the function notation, but that's really a secondary issue. That's more of a grade 11 problem, but we really do need to make sure we know how to do it. But that's secondary to the actual transformation. So I'm going to do the function notation here. So I'm going to do absolute value of x squared minus 4. Okay, so that's my original function. When I apply the function notation, I'm going to end up with x, and then my transformation is going to be plus 2, and then minus 3 on the outside. Okay, so if I have to actually calculate a new table of values for a function, I can use this, but that's not what we're going to do because we've established the function as these coordinates. And we're going to use the red and green transformation to get the new coordinates. We're not going to use this new function here. We're not going to actually use a squared and absolute value to generate new coordinates. Okay, that's not the point. So again, the reason why we did this is so that we can apply function notation to this equation. Okay, but really, again, that's not really the main issue. The main issue is going to be how do I transform the original function into new coordinates using the transformation and not using this new calculation. Okay, so that said, let's do the easy part first. I'm going to do my changes in y. Okay, so I'm going to do my change in y. So my y transformation is going to be, well, I see it on the outside here. I'm just going to take my original x and take away 3. So everything's going to go down 3. So I'm going to do my transformation for y. So I end up with 2, negative 3, 1, negative 3, 2. Okay, notice I didn't touch the x's. I'm just using a transformation to change the y's. The next part here, I'm going to do the change in x. Okay, and I have to remember the change in x is backwards. Okay, so change in x. Okay, this is not what I'm going to do. So this is what I'm going to call my notation. This is what I see. What I'm actually going to do is the opposite of this. So I need to solve for the other x. So I'm going to subtract 2 from both sides. This is what I'm going to actually do. Okay, so then I'm going to take all these coordinates, put it through this equation here, and I get my transformation. So I'm going to go left 2. So left 2, left 2, left 2, left 2, left 2. And there are my new coordinates. Okay, so now I'm going to apply those coordinates onto this graph. And I should see that everything moved to the left 2 and moved down 3. Okay, so I end up negative 5, negative 2, that's going to be one coordinate, a negative 4, negative 3, a negative 2, 1, 0, negative 3, and 1 over 2 up. Okay, so it's going to be 1 over 2 up here. Okay, I think I made a mistake with this one here. This was going to be y equals 2. Okay, so those are my coordinates. It's basically going to be like this, where that's my vertex. I'm going to make the W shape, so I'm going to sketch it in the best I can. So it just bounces off of there. Okay, and there's my absolute value of my quadratic function. Okay, so in every coordinate, if I just track every coordinate, that coordinate moved to the right, or sorry, left 2, down 3. Okay, and every coordinate was translated in that way.